Welcome, ladies and gentlemen. Today we are going to talk about adding and subtracting radicals. Yes, we are working with radicals once again. And once again, you will need your notes, calculator, pen, and or pencil. Here we go. Square root expressions with the same radicand are examples of like radicals. Now, this is important. Here's some examples of like radicals and unlike radicals. To be like radicals, if you look here, they have to have the same thing underneath our square root symbol. Here we have an x and an x. Those ones work, while down here we have an x and a 6x. Those are different, so they're not like radicals. They have to have the exact same thing underneath the square root, underneath the radical. Okay, the radicands have to be the exact same in order for us to have like radicals, which we need in order to add and subtract. Alright. Like radicals can be combined by adding or subtracting. You can use the distributive property to show how this is done. Now, you do not have to write this down, you guys. I'm just showing you here. We can combine these ones because they have the same radical. Okay, same with subtraction. We can do the same thing as long as they have the same radical. Once again, you guys do not have to write this page down, okay? Now, here's a little helpful hint. You can write this one down if you wish. You don't have to. But combining like radicals is similar to combining like terms. So if you want to think about it as combining x values, as long as they're the same. Okay, so as long as these have the square root of 5, we can combine them together. Alright, let's get a few examples going. Here's our first example. First thing we have to make sure is that they have the same thing underneath the square root in order for us to add them together. In this one, we have the square root of 6, the square root of 6, so we can add them together. So all we have to do, what's 7 plus 2? 9 square roots of 6, and that is our answer. That's all we have to do. They have the same radicals, we just add them together. Alright, same with subtraction. They have the same radicals, we have the same thing here and here, so all we have to do is take 3 minus 4, which is going to give us a negative 1, and then we have to write the square root of 6. That, ladies and gentlemen, is our answer. That's it. Make sure you guys are getting all these examples written down, please, okay? Alright, moving on. We have 3 more examples and then we are done for the day. Here we go. We have a negative 2 square root of 3 plus 3 times the square root of 27. Alright, here we have a problem. 3 and 27 are not the same thing. But we do know that there's a perfect square that goes into 27, so we're going to break that down. Alright, I'm going to rewrite this. I'm going to keep it 2 square root of 3 plus 3. Now I have to break down 27. I know the perfect square that goes into 27 is 9. And you take 9 times 3, you get 27. So we need to simplify this again. Can't do anything with the first part, so I'm going to keep it. 2 square root of 3 plus 3 times square root of 9 is 3 times the square root of 3. Now, I can simplify this one more time because I know that I can combine 3 times 3, which would be 9, so I'm going to get negative 2 square roots of 3 plus 9 times the square root of 3. Now that I've gone through all this, we can see that we have the same radical. Okay, they're both underneath the square root of 3. So, negative 2 plus 9 is 7 square roots of 3, and that, ladies and gentlemen, is our answer. Alright, next example, here we go. Same problem here. I have negative square root of 12 and 3 square roots of 3. Now these are not the same, but if we check, there are perfect squares that can go into 12, so let's do this. So I have negative, we can rewrite that as a negative 1 times square root, my perfect square that goes into 12 is 4, times the square root of 3 plus 3 square roots of 3. Breaking this down, I have negative 1 times square root of 4 is 2 square roots of 3 plus 3 square roots of 3. This right here I can simplify. Negative 1 times 2 is a negative 2 times the square root of 3 plus 3 square roots of 3. Now that they're the same right here, I can combine. So I have negative 2 plus 3, which gives me 1 square root of 3. And that, ladies and gentlemen, is our answer. Alright, last example for the day. Ooh, and look at this one. We have expanded, okay? We're adding more than one thing. So first thing we have to do is make sure 18, 12, and 27 cannot be broken down. And in fact, all three of them can be broken down. So we're going to do it all together all at one time. So over here we have 3. Perfect square that goes into 18 is 9. So I'm going to have 9 times 2. Plus, over here I'm going to have 3. We're going to break down 12. Perfect square that goes into 12 is 4 and 3. Plus, we're going to have 2, 27. Now, 9 can also go into 27, and it can go in there 3 times. So 3 times 9 is 27. We're good there. Now we're just going to break it down. So I have 3, square root of 9 is 3 times the square root of 2 plus 3 times the square root of 4 is 2 times the square root of 3 plus 9 square root of 9, 2 times the square root of 9, which is 3 times the square root of 3. Now we're going to simplify all of this. So I'm going to get 3 times 3, which is 9 times the square root of 2 plus, right here, 3 times 2, 6 square roots of 3 plus 2 times 3 is 6 square roots of 3. From here, we have to combine things that have the same thing underneath the radical. Here I have 9 times the square root of 2. Now I do not have any more square roots of 2, so I'm going to leave it as 9 times the square root of 2. Then I'm going to go on to my next one. I have 6 times the square root of 3. Well, I have another square root of 3, so I can combine these two. So 6 plus 6 is 12, so I have a positive 12 square root of 3. And that, ladies and gentlemen, is our answer. Alright, that is all for today. Have a wonderful day, and I will be seeing you soon. Have a good one. Bye. Bye.